All right, well, I know I've got Mr. Black on, I've got Everett on, got Chris. Who else is out there? Anybody?
That's the list as it stands, I guess.
Okay. All right, well, we'll just get started, and we see anybody else come in, we'll say hello. Everybody hear me okay?
Yes.
Everybody should be able to see my screen if you're signed in. I've got a PowerPoint presentation I'll walk through here. So we're all good? All right. So let me first say thanks to everybody on the call, and appreciate taking the time out of your busy day. I want to keep this fairly brief. A lot of content, so it's possible that we could go on and on, but what I want to do is kind of a high-level overview of what we're doing with FuelLIFT and talk is what we're trying to accomplish. Folks on the call and some others that couldn't make it today have an interest in solving a problem. And it's a problem that's been around the industry for a very long time. And I myself, I've been in transportation over 30 years, spent almost 20 years manufacturing, assembly, building trucks in the vocational side of the business. I've been related to the on-highway space since the early 2000s. In my background, I'm an engineering type. I do kind of a experience in my career, but I've done everything from fabrication and assembly to I'm a data guy. I've worked with one of the largest telematics providers in the country. Over 20 years, I've worked with most of the OEMs in doing application engineering, developing product, developing powertrain strategy. Couple of claims to fame. I built an advanced analytics platform that became what people now call their MPG guarantee program. Worked with Navistar to help them build their repair platform and what they do to support the national accounts. My family's been in trucks for years and years. And so I bring a wealth of information as a customer, someone who has purchased basically every engine out there. I purchased most cases the first of a lot of things that were built in the industry. And so the issues that we deal with related to engine vehicles, poor fuel economy, I've lived that life for over 20 years and have been trying to solve that problem. The other folks, Don is he's the guy that we're going to talk about a little bit and is bringing this solution. And Kelly Barker, who many of you have had some conversations with, Kelly's out there trying to get the word out and get some folks to work with us to prove what we have discovered. So let's kind of walk into where we want to go. The page down here. What we're trying to do. So basically, I want to cover in this real quickly, what are we trying to accomplish? What is FuelLIFT? What isn't it? What's the strategy behind the product? What do we know so far? And what are we trying to do next? And talk about the benefits of FuelLIFT and how you guys can help us. So we'll jump into that. And really, this is, it started with a farmer. It started with Don. And Don is like me. he's been around the business a long time, and Don one day had a problem with a vehicle and discovered that DPFs are really, really hot. And if you drive them around fields, you can start fires. And so Don thought that doesn't make sense. Why does my pickup truck with a diesel in it have a DPF dragging on the ground that's starting fires? And what can we do to solve this problem? And that's literally the genesis of FuelLIFT. Journey that just isn't overnight. There's been a significant effort, investment, time, and study. And this is not, just somebody out there making something up. This is has academic study and real engineering behind it. And so we want to figure out how do we understand exactly in the real world what the impact is of what we've discovered, and how do we quantify the actual results that we're getting. So one of the things that just kind of, I want to walk you through the story. This runs parallel with what we know about the existing technology and how we got into the whole mess. So this started with understanding what is a DPF and how does it work. Then we looked at what are the other components in the aftertreatment. What is the DOC doing? And we ultimately figured out, what we should have been solving in the beginning was how do we get better use of fuel, better power, and why do we have all this after treatment and everything on these vehicles in the first place? And so, how do we solve the problem from the beginning instead of making our after treatment better? So, real high level overview. The after treatment system is made up of a DOC, a diesel particulate filter. It has some sensors that measure temperature as well as pressures in the system. And both the DOC and the DPF are basically some type of a matrix of a filter system, and they have materials in them. Those materials are actually embedded in the ceramic, and what they do is they serve as a catalyst to basically raise the heat in the after treatment. And what we're doing is we're burning unburnt fuel in the system. Fuel that should have been burnt in the cylinder, but ultimately what we're trying to do for the sake of the environment, and that's all good, we're all for a clean environment, but what we're doing is we're cleaning up our mess, our exhaust. And so during the process, I just want to kind of highlight what really happens. So think about it. We have an engine, we inject fuel and air, the heat source to combust it, and it produces power. Now, whatever is not burnt, we introduce what we call EGR, which is exhaust gas recirculation. So we're literally moving the exhaust back into the cylinder to try and cook it again. It'd be like taking a stick of firewood, having a fire burn, but it burned out early, so we just light the fire again and try and burn the rest of the wood. That's what we're doing with the EGR. What the after treatment is doing is it is again trying to cook it. So we're the DOC, and then whatever we can't cook there, we're collecting the particulate and the soot. And then when the filter, think of the ashtray in your fireplace, when that builds up again, we dump some more fuel into the system and we cook it again. Now, each time we're doing that, we're actually using a catalytic process, and we're using more fuel to clean up our exhaust. It's really kind of a crazy system. What isn't FuelLIFT? FuelLIFT is not an additive. And what I mean by that is a typical supplements or it adds something to. So typically the most additives in the industry will either do what we call a boost. So we'll add a cetane boost, some type of additional energy source, or we will condition the fuel to use it better to clean it up. So we may have paraffins, leftover waxes in the fuel that plug up our filters. So we will take the waxes out. We'll have water in the fuel. We'll take the water out so it doesn't interfere with the combustion and it doesn't freeze. So we're not additive. Is looking at the function of the DOC and the DPF and saying, hey, rather than cleaning this stuff up, how do we get into the cylinder and how do we do a proper burn and burn it more completely? And that's literally the strategy, is how do we get a complete burn in the cylinder? Question's going to be, don't the manufacturers do this? Yes and no. What they have done is they have solved some of the inefficiencies in the burn, and they do that with injection technology. They do that with compression ratios. They do that with injection cycles. And basically what they're doing, for the most part, from a physical standpoint, is they're using super high injection pressures, and they're using nozzles that create really fine spray patterns. And basically what they're doing is they're trying to increase the surface area of the fuel to make a more efficient burn. The analogy I would use, take a big stick of wood in a big bulk form and try to light it on fire. Very difficult. Chop, you get more surface area, mixing with more oxygen, you add a heat source, and you have kindling. What the cylinder spray injection technology has been doing is trying to produce kindling in the cylinder. Ultimately, what that means is they haven't had the ability to fully combust. And so they're trying to do that under high pressures, and they're trying to do that very, very fast. So they're doing multiple injection cycles, and they're trying to time those injection cycles perfectly in order to get the fuel to combust better. So they are trying to do, and actually they use them in the DOC and the DPF, is they didn't work on introducing a catalyst into the fuel source. So what this is literally a true catalyst. So the question is, what is a catalyst? A catalyst is something that is introduced into an existing chemical reaction. We're not changing the chemical makeup. We are not introducing a new chemical reaction. What a catalyst does is it accelerates and so if we can do that, rather than trying to get perfect timing, try to do it very, very fast under multiple injection cycles, a catalyst theoretically would help burn a complete combustion cycle. And so we thought, let's see what happens. Don was able to come up with a catalyst, and he came up with a carrier to introduce that into the fuel supply. So it's carried by a biodegradable substance. That's why we're talking to farmers. And we have a catalyst supply. So let's talk about some of the science that's gone into this. We discovered that we get a lot of benefits, and Don took this to some technical folks and said, tell me what's going on here. And they studied the engine. They put them on a dyno. They looked in the cylinder and looked at the same tools that they used to develop injector spray technology. And they said, show us what's happening. And the only change is when we have this catalyst introduced into the fuel supply, and when they actually saw a visible difference. And they saw a difference that actually logically makes sense. So if you think about in the cylinder, we're putting fuel in, we're mixing air, and to get diesel, as you know, if you throw a match on diesel, it won't burn. However, if we compress it, we can get the temperature to rise and we can actually get it to ignite. So if you think about in the cylinder, the greatest heat source in the cylinder is in the outside wall between the liner and the cylinder head in a big bore engine. Actual combustion in the cylinder, instead of congregating around the outer edge, it actually moved inward across the entire cylinder head. And there was a visible difference in what was happening in the cylinder. The other thing they were able to do is they were able to look at the combustion and when the combustion took place. And what they found was there was a lower combustion temperature. So in other words, they don't have to rely on perfect timing and compressing it higher and higher and moving to higher injection pressures in order to. They were actually able to get the combustion to start earlier. And so what happens is we get a more thorough, cleaner, more complete combustion. That's what we believe is going on. So if that's true, what will we know? Okay. If we have complete combustion in the cylinder, we won't have unburnt fuel and hydrocarbons that we have to go back and run downstream. The EGR process is going to have less particulate in it. The exhaust temp is going to change, and we can get into the technical aspects of what. We're not burning fuel downstream and we're not doing as much DPF work, then what happens is the exhaust temperatures, which there are sensors forward and aft of the DPF, as well as coming out of the exhaust manifold and going into the DOC, we will see those temperature differentials change, and we'll see them move forward, but we also see the difference what's happening in the cylinder. And the reality is that we don't have to introduce the DOC or the DPF to clean up the exhaust, so we should see a change. Frequency and the duration of everything downstream. Additionally, we should see more energy in the cylinder. So what does that mean? More horsepower, higher fuel economy because we have more energy that's actually being combusted in the cylinder that's getting transferred to the powertrain. We're going to see changing temperatures in the entire system. We're going to see less regen activity. The duration of the regens go down. The regen fuel use goes down. Cleaner EGR, cleaner heads because we're not running particulate back through the EGR. The cleaner injectors and valves, DOC and DPF. That's what we should see. So what happened was they actually went out and tried this stuff. And you know what they're seeing? Better horsepower. They put it on a dyno. Higher fuel economy. Drivers are reporting that it absolutely is a different truck. It has more power. It drives better. They have better acceleration under heavy loads, so we've got more torque, which is the benefit of diesel fuel. We are seeing different temperatures in the system. And when we look at health reports, we look at actual monitored temperature sensors, we see a different regen activity. So what we want to do is look at the entire system and figure out how do we put the math to this. So what we want to accomplish now, stories are great for telling stories. Data tells the truth. I used to buy hundreds of trucks a year. I spec equipment. I work with the powertrain guys. And I can tell you, I woke up in the morning and got an email from the owner of a company that said, I just spent $20 million buying brand new trucks, and this is happening. Are you telling me I'm stuck with this for? And you know what? My heart would sink in my chest. I would turn white as a ghost, and I'd go look at my numbers and say, I hope I didn't make a mistake. So my perspective in this is stories are great. In individual stories, we see them time and time again. We hear them from users that have used the product time and time again. But if I'm going to go make investment in tens of millions of dollars in equipment, I want the data to tell me what's going on. I want the data to do the math and the ROI, so I know what's the return on the investment. That's my mission in this, is to prove the impact, the ROI, how to do the math, and really each of the components in the system, how do we determine what the real impact is in the system? So what we're asking for is we're asking for different users to help us. And we're asking for fleets, one, become a test fleet. Two, collect baseline data. And we can go into the details of what data is available. But we know that, for example, Navistar, Detroit, Cummins, collect data on the ECM. Data is available in trip reports. So we've confirmed that, for example, in a DD13 or a DD15 Detroit engine, we can get in the trip report the odometer, the fuel use, we get idle time, we get DPF fuel, we get regen fuel, we get incomplete regens, we get completed regens, and we can do the calculation of what's the frequency, how many per mile are we getting, and we know the fuel used during that. So with that baseline data, working with test fleets, we will know what the real impact is on absolute gallons, absolute dollars, absolute frequency of downtime, absolute difference in DPF cleaning costs, and ultimately we can say this is the ROI on the technology. And if the math works, we'll know it. If the math doesn't work, we'll know it. But our goal right now is to figure out how do we collect the right data. What I want to do is find multiple apps, isolate small groups. In my former fleets that I managed, I had groups of drivers that tested all the time for me. Not every driver is a good candidate for testing. So we know that not every application is going to be good. Not every driver is going to be good. We're looking for line haul, DC to DC. We want a test fleet of, team expedited line haul, which is going to be cranking high miles very fast. Inner city start and stop. Logically, one of the challenges that we have is that all of the DPF controlled by temperature and operating conditions. So for example, if you have an inner city truck, a garbage truck, you have a bus, you have a short regional last mile delivery truck, those vehicles typically aren't going to run over 20, 30 minutes north of 35 miles an hour consistently. So in other words, they never regen. Other than doing a forced regen parked in the parking lot, they never clean the system. And so we would expect that those applications would have great impact. The line haul trucks, we know that they're not going to do the passive regens going down the road. But we want to measure each of those different applications. The other thing we want to do then is figure out how do we introduce it into the fuel supply. What I know in this business is if we can prove the need is there, the delivery method into the fuel supply will happen. We've got to prove that it works. Now, for the test purposes, any LTL operations, anybody regional with on-premise fuel, where we don't have to, we can take the driver out of the equation, that's better. That will work with us that have on-premise fuel, and then we can scale those up into larger test groups. Ultimately, it's easier there because we can blend as we go right into the storage tank. We know that it's stable. We know that it's homogeneous, so we don't have to worry about once we introduce it, we just need to dose it at the right rate. Once we get the controlled tests, here's our intention. We're going to get the key data. We're going to log that and compile it. We're going to grab it from the telematics providers as well as manual templates. We're going to build a data model, year, make, model, engine, application, fuel economy. We're going to know all the impact. And quite honestly, this is the exact same data that I use when I'm working with fleets. I'm engineering their spec. I'm working on their application, their fuel economy savings, their maintenance savings. I'm going to use the same algorithms, the same analytics that I use in what I do every day. And then we're going to publish this back to the participants, and we're going to use that data to come up with the ROI calculators that will then say, you put your own data in, you put your own fleet data in, analytics, and it will tell you, does this make sense for you or not? But ultimately, we want to tell you that we know that it's working anecdotally, but we've got to measure it correctly so we can all make good decisions. So what we're going to do is we'll reach out and we're going to send you a note, and we're going to ask you, how can you help? If you can send us trip reports, we'll give you templates, and you can tell us what engines, what telematics, what type of application you run. If you've got drivers that you, and we'll work with us. We'll work with small groups of drivers. We absolutely need to take any variables out. So, we've got to work with guys that are used to doing that, and they understand the importance of collecting the data correctly. And then if you've got fuel on site, if you can send us DPF cleaning data, if you've got something on site where you do your own cleanings, you're going to do pressure tests on those DPFs. You're going to do inspections visually. You're going to do DPFs as you're cleaning them. And so that data will change over time as well. So we want to get as much of that data as we can. With that, I'm pretty much done. Any questions? Might be a little busy with lots of folks on the call, but if you've got any questions, I'll take them. Otherwise, feel free to reach out, send us an email with your questions. We'd be glad to schedule another call or a meeting with you, and we can talk about any of your other questions that you have. Kelly or Don?
We're here.
Any comments, or you want to add anything?
Well, my only comment, this is Kelly, my only comment is that once we compile this data, I mean, it changes our ability to sell the product. And it also changes people's ability to produce a profit when they're able to reduce their overhead on a number of different things, fuel usage, repairs. One of the things we didn't touch on in the oil. So, and as hard as that carbon is when it's in the oil, that's by itself a huge deal. So, comments, I cannot wait to start collecting some of this data, because of course I'm the guy that's been out there dealing with only anecdotal, commentaries and trying to sell this that way. So I look forward to the day when we can actually have the proof of what I know the product does. I'll hand the phone to Don, and let's hear what Don has to say.
I want to thank you very much for putting this on, and any way that I can help, product, supply product, to get the test done, and I'll even go out and put it in the tank if that's what they want. But I appreciate you very much, Tim.
You bet. Thank you.
Thank you.
Anybody else have any questions?
Not at the moment. Covered everything fairly well.
Good. Well, we appreciate your time.